All right, so a curve is a continuous set of points. It's any kind of line. It's not a straight line. It can be a straight line. Doesn't have to be. It's anything you can draw without picking your pencil up. So that's a curve. That's a curve. That's a curve. That's a curve, right? They are all technically curves if you can draw it without picking up your pencil. But like those two things together would not be a curve because I picked up my pencil, okay? All right, I'm going to erase my dramatic curves there so I have room to write more stuff. All right, but does that make sense to everybody? Yes?
So is cursive like curve?
Technically, yeah. Like, I'm not picking up my pencil, right? Curve. Okay, so then we have some more specific types of curves. All right, so the next one we're going to talk about is a closed curve. All right, any guesses on what a closed curve is?
Circle.
Right, so it could be a circle, right? Right, so it basically means that your curve stops and ends at the same point. Right, so yes, a circle is a great example of a closed curve. Right, but again, I'm going to start here. I'm going to draw that dot, it's just so we know. Like, I could do this. But look, I'm starting at the same point. As long as you start and end at the same point, it's a closed curve. Yes, I was extra dramatic on purpose. Right? But, so let's, again, so starting and ending at the same point is a closed curve. Okay? All right, questions on closed curve? Okay. Next, we have a simple curve. So that's just a curve that does not overlap itself. Right, so like a simple curve would be something like this, or like this. Right, even like this. But it's not a simple curve if it crosses back over itself, right? That makes this not a simple curve. Right, but there it's a simple curve, okay? Just can't cross back over itself. All right, and then our last one is a simple closed curve. Any guesses on what that one would be?
Curve that closes that can't overlap.
Right.
So like a circle.
Yeah, so a circle is more specifically a simple closed curve. It's also a closed curve, but it's simple because it doesn't cross over itself. So it starts and ends at the same point and no overlap. So again, trying to make it fit. So again, like I said, it could be a circle. It could also be whatever that weird shape is I just drew, right? As long as it doesn't cross over itself and it starts and ends at the same point, it's a simple closed curve. Did everybody get this part?
Not yet.
All right. I take your time, just let me know when you're ready.
Sure.
All right. Okay, so our next definition is a circle. So, a circle is the set of all points that are a given distance all right, so basically what that means is you start with a point. And so the circle that forms then is all of the points that are the exact same distance from that center point. Right. And does anybody remember what we call the line that we draw from the center to the edge of a circle? Radius, right? Right, so that's the radius of the circle. That gives you that distance. So that distance from the point is your radius. All right, so do we get a circle? I was going to say, I know you guys have talked about circles at other points of your life. But
I'm still writing down with them.
you're good. I see that you're still writing. You're okay. Just checking in about circles. Circles are fun. We will probably have a circle drawing contest later this year. It's fun. No. Freehand circles. Whoever draws the best one gets some bonus points. We do that when we do this. We have a whole chapter dedicated to circles later, so. Huh? We will celebrate Pi Day, yeah. Although now every day, well. All right, moving on. Let's talk about polygons. So, a polygon is a simple closed curve. What does that mean?
Close that into the same point.
Right, starts and ends at the same point and
It doesn't cross over it.
doesn't cross over itself, right? But it's made of only segments. Right, so since it's made of line segments, that means all of the side are like straight lines. All right, so while I know it's kind of hard to like draw it without picking up your pencil, it can be done. Right, and so each segment is the side, so segments are the sides of a polygon. And then where the segments come together, so the endpoints of the segments are called the vertex or vertices is the plural. So let's say, for example, all right, that's probably the best hexagon I've ever drawn in my life. All right, so again, the sides are the lines there, right? So like if they were labeled with points. Right, so like segment AB is a side, segment BC is a side, CD, and so on. But the endpoints, so like, are these actual points right here? Like, so those are your vertices. And then again, like this, these are the sides. I'm going to kind of go over them in red so you guys can, does that make sense? So when I say side of a polygon, I'm talking about one of the like straight edges here. Next, we have an equilateral polygon. All right, anybody remember what equilateral means? Yes, Ike.
That they're equal length.
Yeah, so all the sides are the same length. I'm going to say the sides are congruent. Because remember, congruent means that they have equal lengths, right? All right, so that's equilateral polygon. All right, so then we also have what can be called an equiangular polygon. All right, so if equilateral means all the sides are the same length, any guesses on what equiangular means?
The angles of the polygon are of equal angle.
Yeah, so all of the angles in the polygon are the same measure. So all angles in the polygon are congruent. And then the last one we have is called a regular polygon. And that is just a polygon that is equilateral, so all the sides are the same length, and equiangular, so it has congruent sides and congruent angles. So again, a chord is a segment whose endpoints are on the circle. So if we were going to draw a chord, right, it means it starts on the circle, goes across, also ends on the circle. All right, so you can draw that anywhere in the circle, but that would be a chord. Right, then we have diameter. Right, so that's just a chord that contains the center of the circle, or that goes through the center. All right, so let's give our circle a center point here. So the diameter would be a chord that just goes straight through the middle and includes that center point. All right, and then the last one is an arc, and that's just the curved like portion of a circle. So like arc AB, you write it like that with a little arc over it. It just means that you go from A to B, and it's like that curved outer part of the circle. So I'm just going to put curved part of circle. So the arc is just like a curved part of the circle. Right, so curves go on the outside, chords are like the straight lines through the middle.